In question 16, part A asks us to find b minus a if a is equal to 2.4 times 10 to the power of negative 4 and b is equal to 4 times 10 to the power of negative 2. And it wants us to give our answer in a decimal correct to two significant figures. Okay, so let's write out what we have for part A. We want to find b minus a, and b is 4 times 10 power of negative 2. A is 2.4 times 10 to the power of negative 4. Okay, so what we want to do here is change each of these numbers in scientific notation to their decimal form so that we can subtract them. And so let's do that on the side here. You can think about this, if it's not immediately obvious to you how we change it. I think we have 4 times 10 to the power of negative 2. And 10 to the power of a negative number is the same as 1 over 10 to the power of that number. So that's the same as 1 over 10 to the power of 2. 10 to the power of 2 is 100, so this is the same as 1 over 100. And we changed that fraction to a decimal at 0.01. 4 times 0.01, 0.04. So that's the decimal form of this number in scientific notation. Write that here. And we can see that what we've done essentially, since we have a negative 2 power here, we've moved the decimal over. If we think about this as 4.0, we've moved it over to the left by 2 spaces to make 0.04. So that's a quick, an easy way to go between these two forms. So let's do that for the second number we have here. We have 2.4 times 10 to the power of negative 4. It's a negative number, so we're moving the decimal to the left. In this case, we're moving it 4 spaces. So that is going to end up being 0.00024. So you can see from 2.4, we've moved it 1, 2, 3, 4 places to the left. Okay, so now that we have these decimals, we can subtract like normal. And when we subtract this, we get 0.03976. Okay, but the question asked us to express our answer correct to two significant figures. So that's going to be this placeholder here, or sorry, this value here. And if we round this, we're going to end up getting about equal to 0.040. That's two significant figures. We can see that that is essentially the same value as b. And so if we think about this, a was just so much smaller than b that subtracting it and then rounding really didn't do anything. So our answer to part A is 0.040. Let's move on to part B. In this part of the question, they want us to find b to the power of 3. Okay, b is 4 times 10 to the power of negative 2. Doing that to the power of 3. And in this case, because this is just a multiplication in here, we can apply this power of 3 to the 4 and to the 10 to the power of negative 2 separately. So 4 to the power of 3 times 10 to the power of negative 2 to the power of 3, like that. So 4 to the power of 3 is 64. And here we have 10 to the power of negative 2 to the power of 3. And when we have a number with an exponent to another exponent, we just multiply the exponents. So negative 2 times 3 is negative 6. So here we have 10 to the power of negative 6. And we can rewrite this in scientific notation, but this isn't quite right because we want the number to be greater than or equal to 1 and less than 10, like it asked for in the question. So that is going to be 6.4. If we think about how we've moved the decimal to make 6.4, we moved it to the left 1. So that means that we need to decrease this negative value sign, because this negative 6 is asking us to move the decimal to the left 6 spots. We've already done 1, so we only have to move it 5 spots, if that makes sense. So 6.4 times 10 to the power of negative 5 is our answer to part B. In part C, they want us to find 5a over 3b, giving our answer in ordinary notation. So if we write out what that is, a is 2.4 times 10 to the power of negative 4. And we have 3 times 4 times 10 to the power of negative 2 on the bottom. Okay, again, this is all just multiplication and division. So we can multiply this 5 in, multiply by 2.4. And 5 times 2.4 is 12. Keep this 10 to the power of negative 4 here. 3 times 4 is also 12. We have a 10 to the power of negative 2. So we have a 12 on the top, 12 on the bottom, and those just cancel out. And we're left with 10 to the power of negative 4 over 10 to the power of negative 2. So we have the same base here. So what we can do is, because we're dividing, we subtract the exponent. So this is the same as 10 to the power of negative 4 minus a negative 2. Okay, so if we evaluate that out, negative 4 minus a negative 2 is the same as plus a positive 2. So that's going to be a negative 2 on the top. So we have 10 to the power of negative 2. But the question asked us to give it in ordinary notation. So again, we can just change this to a decimal like we did up here. So this is the same as 1 over 10 to the power of positive 2, which is the same as 1 over 100. Converting that to a decimal is 0.01. So 0.01 is our answer to part C. And those are the answers to question 16.